Alright, quicksort. Here's how quicksort is going to work. We need an array or some other type of collection. I have a simple unordered array. What we do is that we'll pass our array as an argument into a quicksort function. After passing our array as an argument to the quicksort function, we need to pick a pivot. There's different variations of quicksort. We can either pick a pivot at the beginning, the middle, or at the end. But with most standard quicksort algorithms, we will set the pivot to be at the end of our array. What we're trying to accomplish is that we need to find the final resting place of our pivot. Where is this value going to be? And taking a look at this, that would be right about here. But we don't know that yet. So to find the final resting place of this value, our pivot, here's what we can do. We will declare and use two indices, j and I. J will begin at the start of our array. I will be one less than the beginning of our array, and that's going to be important later. And we'll need the help of a temporary variable so we can swap some values. All we're doing is checking to see if the value at j is less than our pivot. If it's greater than our pivot or equal to our pivot, we ignore it. 8 is greater than 5, we ignore this value, and then increment j by 1. So during that last iteration, I did not come into play yet, but it will this round. Again, we check to see if this value is less than our pivot, which it is. What we do now is increment I. Then what comes next is that we swap these two values, I and j, and we'll need the help of a temporary variable. So take the value at I, assign it to temp. Take the value at j, assign it to I. Take the value within temp, assign it to j. Then we can move on to the next iteration. Increment j. We check to see if the value at j is less than our pivot, which it is. If that is the case, we increment I, swap these two values. We'll repeat this process until j reaches our pivot. Then we can move on to the next step. Here's the next step after our index j reaches our pivot. We now know where the final resting place of our pivot is going to be. It's I incremented by 1. So we will increment I, then swap the value at index of I with the value at our pivot. Our pivot is now within the correct place. An easy way to tell is that all elements to the left of our pivot should be less than our pivot, but they're not necessarily going to be in order, and that's fine. They'll be organized later. All elements to the right of our pivot should be greater than or equal to our pivot. And like I said before, they probably will not be in order. The important thing is that elements to the left should be less than our pivot. Elements to the right should be greater than. That's how we know the pivot's in the correct place. Now the next step, we're going to create two sections, two partitions. The first partition will be all the elements from the beginning of our array up until our pivot, but not including the pivot. And our second partition will be all the elements after our pivot until the end of our array. Quicksort is a recursive algorithm. We need to pass these partitions as arguments into the quicksort function. Remember that the quicksort algorithm is a recursive divide and conquer algorithm. But unlike with merge sort we create new subarrays. With quicksort, we will be sorting these arrays in place, but we need to keep track of the beginning and ending indices of these partitions. And then it's just a matter of repeating the same steps over again, but we're going to instead use these partitions, sections of our array. I'll give you a quick demonstration of what the quicksort algorithm is going to look like to completion. And that, ladies and gentlemen, was your visual representation of the quicksort algorithm.
This code demonstrates the quicksort algorithm, a popular sorting algorithm. It works by dividing the array into smaller subarray, sorting them recursively, and then combining the result. Quicksort function is the core of the algorithm. It takes the array, a low index, and a high index as inputs. If there's more than one element to sort, it calls the partition function. To find the pivot index, then it recursively sorts a subarray on either side of the pivot. The partition function arranges the element around the pivot, with element less than the pivot on the side and element greater than the pivot on the other side. Finally, the main function creates an unsorted array. Calls the sort function to sort it and print the result. We're done. Let's check if correct. Oh, the code is right. Then thank you for watching, and just like the notification bell. That's all for today. Let's call a day.